Okay, I'm Paul Albertella. I've been working on Codethink safety approach since, well, at least 2020. I kind of joined ELISA in 2019, and I'm now been the chair of the ELISA open source engineering process group for a while.
Yeah, I've been working in Trustable in Codethink. I started in hardware background, doing a PhD, and from there I went to a cybersecurity project and got interested in how to improve things in knowledge management, let's say, and that's how I ended up where I am at the moment.
So we're here to introduce the Trustable Software Framework, what it is, how it can help, how it differs from established approaches, and how it's going to be applied in practice. And we'll also tell you where you can learn more and start using it yourself.
I do have a question. In the audience, how many of you have heard about Trustable before? So I would say it's like a 50-50 split.
Okay.
Initially, Trustable, as you can see from the slides, it was based on guiding practices, good practices in software engineering. They were put together based on Codethink's experience. So we're a consultancy company working with many various companies. And we compiled this and published a white paper. The Trustable Software Framework is slightly different than Trustable just on its own. It's building additional guidelines on top of it, how to support the management of knowledge, requirements, documentation, success metrics, observability, how do you do analysis, how do you see the test results, and so on, and how can you package all of that for compliance.
So what are the problems we're actually trying to solve here? I mean, the first one's obvious. It's how can we actually trust software in a particular context? And I've crossed out the open source software because often this is open source is the problem here, but it's software in general that's the challenge. It has a key role in many critical applications. Open source software is increasingly used in those contexts, or at least people want to use it in those contexts. And in a lot of cases, it's used anyway. People use it in the tooling. They use it in libraries and things, and they just conveniently forget that. And the established formal engineering approaches are just not keeping up with this, not just with the open source, but with just complex software in general. This is the kind of the slide that illustrates this, because it's not just the software that's getting more complex, it's the hardware that's getting more complex. The ISO 26262 world of a single microcontroller and a few thousand lines of code is really not the same territory as where we are now, where we've got millions of lines of code in a software system. And we're not just talking about several multi-core, microprocessors, we're in some cases talking about many complex ECUs interacting with each other. So this means that software is a bit of a moving target. Critical software has historically been small and small scale and relatively static. You verify a golden version and that's it. You stick with it. You change it as little as possible. But modern software is increasingly complex and frequently updated. And the Linux kernel is a very prime example of this. But there's also changing expectations about software's role in systems. It's not just a simple control algorithm. It's something that's doing a lot more, and it has a much more central role. But it's also that consumer expectations, and in particular product marketing, is kind of reflecting this. Yeah, if you're talking about software-defined vehicles, you know software really is changing in its role.
So in this talk, we want to show how Trustable Software Framework encourages projects to document the top-level objectives that are a little bit more stable and continuously evaluate the software in relation to these.
So this is in contrast to what I've described here as paper-driven process models. Clearly, they don't always write it on paper anymore, but sometimes the processes behave as if you do. You have a document. You probably write the document in something like Microsoft Word. You kind of keep it in some document management system, but it often has very little relationship with the software that you're actually developing or the artifacts associated with it. And you can use some fancy management systems to help with that, but in the end, there's this inevitable disconnect between the two. And even if you can get that right, the traceability gets harder and harder, and it's really not been designed with continuous development at scale. And it certainly didn't develop distributed development of components that you're then bringing together to integrate and create those systems.
Again, as a solution, Trustable Software Framework is thinking that since source code is managed in version control, the software project's objectives themselves, the intent behind the code that you might not immediately see, must also be managed in the same way. Hence, Trustable Software Framework has one dependency, Git.
So these paper-driven processes or their modern successors can also be misleading. The document processes end up not matching the actual engineering practices, and you can't find all of that just with an audit. But it's also, you don't actually have the claims that you documented with a clear link to the evidence. Your designs don't reflect the implementations. And however you do any of this, the reasoning and the intent behind your design choices is often not documented. And not because you can't, but in some cases because you don't think you should. Assumptions are documented because, well, everyone knows that. Or limitations are not documented because they might send the wrong message. They make your software seem like it's unreliable in some way, or they might make your team look bad.
As a solution over here, the Trustable Software Framework uses a model which is meant to manage all the metadata for all of the project artifacts you may have or deem critical, using references with hashing mechanisms to provide a common map of all of the territory of the supporting evidence to assess trustability transparently, visible for all, such that all omissions are also visible. And
then we've got requirements themselves, and as anyone who's worked in software for any length of time, requirements are largely broken. High-level requirements are a wish list. Your stakeholders just write down what it is they want, with sometimes just describing the solution they think they need rather than what the intent was behind it. And low-level requirements are a narrative. You describe what you did, and then you say, yes, here's the requirements. And that can mean that the traceability is either a myth or just a paper exercise, which is demonstrated when you have tests that end up just being a self-fulfilling prophecy. They demonstrate what happens without demonstrating why that's important.
As a solution over here, Trustable Software Framework is designed to allow contributors to document and also users to assess the reasoning leading from the high-level objectives to the evidence that you have tracked.
And which brings us back to open source software and the problems with it. Sometimes, actually, these problems aren't really a problem. The dynamic nature of projects might seem like a problem, but actually it's how you get rapid iteration, how you get lots of people from diverse backgrounds contributing and producing working software. The trouble is that they rarely maintain their documented requirements or even think that requirements are important, and they don't verify against them. They might have tests, but it's hard to link these back to requirements. But these can be a strength as well, and that's why people want to use software. That's why open source software is popular and why it is actually getting so widely used. So we have to accept that there are strengths and weaknesses, and if we can actually find a way to work with the practices that are familiar to open source software, then perhaps we can start to address those.
As a long-term vision over here, when Trustable Software Framework gains wider adoption, the open source projects themselves become more appealing option for solution developers or any integrators, product developers, OEMs, in return for increased visibility and insights for projects, both for the developers themselves and for the users. Let me then we saw the context, we saw the problems, we saw the proposed solutions. Let's start digging into and decomposing what the framework is. As its main design objectives, it's meant to be lightweight for continuous compliance framework, meaning that it must be evidence-driven, have a core principle that everything that you claim must be backed by an evidence, and all of this metadata is maintained in the same environment as the related artifacts, source code, binaries, test results, whatever. It therefore mainly focuses on objectives that are being tracked or claimed rather than the processes, such that we know that the open source communities don't really follow very rigid processes. They're more implicit than explicit. Whatever those processes are, they still come up with some measurable metrics, measurable outcomes, and these objectives, if we can capture them and measure them, this gives us a body of evidence we can use for various needs. To do that, to be accessible both for open source communities, it has to be workflow agnostic or even tool agnostic, such that whatever existing processes code has been followed could be adopted to be compliant to the Trustable Software Framework. These are the main design principles around Trustable Software Framework. Let's break down what the framework actually means. So in general, framework consists of these wonderful little colorful icons that you should keep an eye on throughout the rest of the presentation. The first one is the objectives, defining what is important for the project. Then the framework is using a model. A model, by definition, is a simplified description of a more complex system or idea. Some in this conference have said design of a system is difficult to see from the code itself, so you need a model to describe the design. But the model itself cannot do anything for you if you don't know how to effectively use it, so there's a methodology, a system of methods used for a particular activity. Then there are tools, of course, that assist you, and documentation to tell you what's going on or how to improve. Let's start from the objectives. So trustable, these are the good guiding principles that we have found. These are ever evolving, and this talk is not really about this graph. This talk is about demonstrating how you can use these objectives and expand them based on for your project and how you can use it. What this graph essentially is a starting point for your journey, and you will start building both under these objectives as you expand on the model and also making it more wider with your own objectives. How do you capture all of this is the graph, and the graph is what we call the Trustable Software Framework model. We will go through more details of what these different words means, but at the essence, you make statements that each statement can be interpreted as a request or a claim, depending on whether you're requesting something to be true or you're claiming something to be true. And it's either an objective to be achieved and or how it is achieved, given the context. These statements are linked to artifacts to either qualify the objective or to provide evidence that this indeed has been achieved, such that any either developer or a user can assess whether the statement is true or false. The methodology is a fairly simple best practices in software. You apply the model, the framework in context as much as possible. You document your project-specific objectives, reasoning for your software in its development processes, link to requirements and evidence managed in your project. You map your claims and evidence to the trustable objectives, and you map your trustable graph that you have achieved as a result to project-specific objectives and evidence to external requirements. For example, if you're using Trustable to meet any standard compliance. The tools are the things that help you process all of this. They help you manage the graphs and manipulate them, and as a result, you can also produce reports. They can be HTML reports or be Markdown reports, but in those reports, you can see what impact any change has to your existing claims or objectives or metrics. And then you can integrate this, of course, with automated testing to get kind of a live dashboard feeling on how the project is progressing. And with this, you can start building confidence or measuring confidence in the trustability of your project to give immediate feedback to existing developers and also users to identify any gaps or where we should put additional effort into. Of course, this Trustable Software Framework also comes with documentation. There's a link in the slide set, but there's some additional guidance as well. For example, for higher integrity workloads, we suggest you follow the RAFIA, which is risk analysis, fault induction, and automation approach, which essentially says do an SDPA. From that SDPA, you derive some requirements, constraints, meet those constraints with tests, and then analyze those results. And you go into a feedback loop. And this is an example process you could follow. And from that example process, you derive some objectives that you can see and show how they have been met.
So how does TSF differ from the traditional approaches, which you said were not working? So the most familiar way of looking at this is the V model, which is this illustration here, where you start with some system and user level requirements. You specify your system architecture, you validate against its requirements, you assign requirements to components, and you document your detailed requirements, and so on and so on and so on. And this is nice, and it works really well where you're starting with a specific goal in mind, you've got complete control over the development process, and you're working in a structured way, even a phased way through this. The myth that this is a waterfall that only goes in one direction is as we know, not the case. There may be some iteration in this, but it ultimately boils down to a phased approach and a formalism and a kind of formalized structure about how you link these things together. The problem with this, as you'll see from the bits on the outside, is this is what we're describing as the paper-driven approach here. It's based on this idea that there is documents that don't necessarily have very much in common with the source code or the binaries or anything else to do with the software itself. Making that link between them, making that connection is where the problem ends up being. So how is TSF different? So it's built around a Git-based continuous integration workflow. It has Git's its only dependency, but it does have an expectation that you're doing continuous and updates and change via this continuous integration workflow. The idea is to manage the metadata relating to your software in close proximity to that software. And that means managing the documentation relating to your software in the same way and with the same change management processes as the software artifacts. This means that you can do impact analysis of changes as part of your processes for all of these things. If you're changing a document, you can actually assess what impact that documentation change is going to have on the wider set of goals and objectives for your software. And that's really important. But it also assumes an iterative approach, which means that the order of the phases that we're seeing in the V model are much less important than the incremental progress towards the objectives that are actually captured by those things. So we're not saying that the categories that are in the V model are not important, because they absolutely are, but doing them in a particular order or starting with one and then not proceeding to the next one until you've done it, that doesn't make sense, particularly since you're kind of always discovering new things, and changes can happen to all of those things at any point in your process. If you don't want to be, I guess, enslaved to that formalism of the phased structure, then you need a different way.
There's an interesting thought that potentially traditional compliance models can encourage a race to the bottom. If you have a set benchmark and a very competitive field, a lot of the projects will try to meet that benchmark as cheaply as possible to be the value differentiator. But Trustable Software Framework enables transparent self-assessment that gives you a way to showcase, one-up your competitors, that you have a higher level of standards than others, and you have producing a higher level quality of reasoning and evidence.
So how does it work? Well, as we said at the beginning, you start by identifying what are your key objectives for both your software and for your project. So this doesn't mean starting with a comprehensive list of requirements. You're talking about your top level goals or your most important criteria. It doesn't mean you're going to ignore the rest of those requirements, but it means that you need to start by focusing on those, because that's what you really need to concentrate on. So that means using your existing documents for inspiration and including them by reference to those high level objectives. The key with these objectives is to write them as statements, one sentence where possible, which can feel like a terrible restriction, but actually really makes you think about the problem much more clearly. We've got some recommendations about how you frame those statements, which I think you can judge for yourself whether they're a good idea or not. We don't like using shall, should, must, and things like that, because actually really we're trying to state what needs to be true, and then you can evaluate whether or not that is the case.
Once you have made those statements, you need to start linking them to each other, and essentially, as I said before, you express requests and claims, and those requests and claims will then be qualified by an artifact, or you evidence it. But we will see further how we can expand on this model. But first, an example.
So this is an example from the Safety Monitor project, which has been applying TSF in the open. And it's got an example of saying a high-level objective. SPIs in this case are safety performance indicators, and it talks about the particular mechanism that's used to achieve that high-level objective in Safety Monitor, and then gives links to 2 examples of the test cases, so that basically a description of what the tests are required to show that. So then the actual evidence that we're linking to of those tests is then going to be where we're having to link to the artifact. And that means the actual test code and the actual test results.
Now, the same thing is done for the trustable objectives at the top. The trustable objectives are first broken down to different tenets that are a generic set of expectations for trustable software projects. Those tenets are then broken down to assertions. But a project implementing the Trustable Software Framework extends this, first with its own expectations, where you can kind of form independent trees within the graph. You can have multiple roots for this tree, making it a graph, and you can also build assertions and evidence relating to the trustable assertions in the trees to make it deeper.
So the key here is about integrating this with your project, which is why the actual representation of the graph is stored as text files in Git. Because remember, you really need Git here. That means that the changes to the graph, so the way you're expressing the metadata, the way you're expressing your objectives, are tightly coupled with changes to the project. And because you can reference artifacts, that means that if you've got an objective or a statement about an objective which is linked to a piece of code or to a document, you can say, well, hang on, if this document changes or this code changes, I actually need to review this and see whether it's still true. And the same thing works around. If I'm changing the objective and the evidence it was pointing to needs to be reviewed to see whether it's still true. And we also use hashes to detect these changes, both in the links between statements and in the changes to the referenced artifacts.
How does it work in practice? At the top, you have a SMA Safety Monitor Assertion 7. It has that single sentence we saw before, but you also have a different file that essentially contains all these identifiers and the hashes that are related to the relationships between the identifiers and the text themselves, such that if something changes, you can see that.
And you might be saying, well, why is this really necessary? I mean, you're doing it in Git. There's a reason you're using Git, because Git's really good at managing this kind of complexity. And it tracks changes. So why do I need to store hashes too? Well, the thing about this is that because Git ends up having little minute atomic changes that don't necessarily convey these or respect these the relationships between your artifacts, you need a way to say, well, hang on, if I change this, then I need to look at this over here as well, because actually these two are related, and I need to make sure my change doesn't break this. So the next obvious question is, does this mean I have to store absolutely everything in the same Git repo? Well, no, because that would be insane. But because we are using Git here, we can actually very, very precisely reference things in other Git repos. We can say this particular version in this SHA of this Git repo here is the thing that I'm referencing here. And then if you set your CI up correctly, you can then see when that changes. And because you're referencing a SHA of it, it shouldn't change. If it does, something's gone wrong, and your tool will tell you. But unfortunately, you do probably have to store everything in Git, unless you've got something that you think you can trust as much. So if you have, for example, a requirements management system that you want to reference in this and you trust it, then by all means, as long as you've got a nice unique reference that you can include to link to it and a way for us to check them, then fine, knock yourselves out.
Now, let's talk about evidence. Evidence is also related to artifacts and referencing. You can reference any middle-level reasoning statement, which is making essentially a qualifying that single sentence to have a little bit more rich context, or you can use a reference to support a claim. There are two types of evidence. One is, as I said, a reference, but another is a validator, which essentially uses automation to check either is the test result true or false, or whether some statistical thresholds have been met or not.
So evidence means artifacts, and that means we're making claims about artifacts with respect to a request made by another statement. And we're trying to talk about artifacts that relate to the software. Now, that might be a document about the software, or it might be a source code, or it might be a test file, or it might be a result. And the key here is it's the results of software engineering processes applied as part of the development. So if you're looking at input artifacts that you're storing in Git, that's one thing, that's great. You can use references to see when they change. But if actually what you're interested in is the test results or the statistical analysis of the test results, then clearly you need to be able to reference something that's going to be a result of a CI process, or possibly a result of a query on your storage of a whole bunch of data you've accumulated over time, and that's where you use a validator to say, use this query or look at this result and perform these steps on it to determine whether it's meeting these criteria.
A little example again, we see evidence statement being made at the bottom, but at the top front matter, there's various metadata in the YAML format where you reference what type of reference are we dealing with, what the path is for the data to be found, and some kind of additional identifiers that are needed for the type of reference you're making.
So the key is we're using this as part of a project CI because we want to be able to check the effect of that CI process on our graph as well, because our graph is the thing that's guiding all of our principles. And this means that we can reference the results of CI jobs as evidence in the graph, because we're then going to actually, as part of a job in our CI, update the graph and say, right, let's check this later on to see whether that test result actually exists, or were the range of values I needed to see from that test result, did they actually hit the thresholds I was looking for? So the validator plugins that Kaspar mentioned earlier, the implementation we have is essentially they're a piece of Python which you can use to perform some actions on some data. But how you extend that to your own use is the intention of having this scalable framework.
Again, let's put it into something concrete. Here you can see in GitLab CI, you have some kind of a linting stage. You identify a container and you run the tooling, in this case, linting. And you want it to fail on error, you specify artifacts, and you have a dependency on running some test stage before that. And you have an example output of the tool, which is essentially warning you that you have unreviewed items or suspect links in the graph. There's both the item itself can become unreviewed, or the link between two different statements has become suspect because one statement has changed without verifying whether the related statements are still true.
And here's an example of that actually causing a failure. So these are this is an example of the evidence that we're talking about here. So in the previous example, we saw that individual tests were referenced by the evidence items. So this is actually looking at those individual tests have passed. It's a trivial example, but I think the point to convey here is that if one of those tests failed, actually, in this case, the job would fail, so the CI process would probably fail anyway. But also, your graph is then going to be updated to say, why did this fail? It's because these tests failed, because I've got a score of 0 in my graph.
Now, all of that information is then collected together into a single report. These reports are generated based on the graph at the end of your CI pipelines, when all artifacts are then visible and collected. And then you have to start scoring some statements over there, whether you believe that the evidence is sufficiently collected for any statement that you made. This scoring is done by humans. You can't take the human out of the loop completely in some cases, and they are subject matter expert assessments. But once you collect them enough over time, based on, let's say, big enough amount of people have collected enough data, it becomes a reliable source of information.
And so the point of this is to allow you to both track your progress, track whether your objectives are actually being achieved, but also be able to trace to the evidence. So if you want to be able to say, I've got this high-level objective, how am I actually showing that that's true? If I've got a green thing for my high-level objective here, why do I believe that? And then you can follow it down and say, this is the reasoning. I'm saying these things need to be true. I'm saying these things need to be true. Here's my evidence for all of these. I can then go down and drill down and look to the actual evidence that's supporting my statement.
Now, how can it help with continuous compliance is, again, based on these reports, if for all changes you can map your own objectives against any kind of compliance objectives, you have live data all the time, what kind of reasoning is being made, who has reviewed it, who has made changes that made some statements invalid or valid. You have that information visible. You can kind of think of the Trustable Software Framework itself being a compliance scheme for Trustable, to kind of see how these two terms relate to each other. But the main idea for the Trustable Software Framework is to be very flexible, such that you can use it how it makes sense for you.
So as an example here, if you want to comply with IEC 61508, you can break that down into objectives, which you're actually describing in the same way that you were describing your own statements. You've got that sitting in parallel with the trustable objectives, because they're different ways of looking at the same problem. And then you're actually able to drill that down to your reasoning and to your evidence to say, well, given this evidence here, I am able to support this objective of the standard. Actually, my trustable objectives don't cover this aspect that's important in the standards, so I need some more evidence here, or I need some more reasoning. And when you actually put those together, you're then able to kind of say, okay, I'm completely compliant with Trustable. I need to do some more work here to comply with IEC 61508. And if you build the evidence and the reasonings together, you end up with being able to evaluate your compliance with whichever standard or whichever scheme you're actually choosing to look at. That's the end of our presentation. There's a lot more information you can look at. There's some previous videos and talks that we've given, which go into more detail about the trustable objectives themselves. But we would very much like to talk to people. So give us your questions.
Thanks for the presentation. Like at the very beginning, you showed like what are the strengths of the FOSS, like open source projects, and then also the weakness. One of the weakness you mentioned was lack of documentation. Mm-hmm. And then like with this TSF, what I understood, we have to write the documentation at the end. So if you think about a project, open source, multiple contributors, multiple developers, how does it solve it? At that time, the solution is write documentation.
That's a good question, yeah. So the purpose of this is really not, it's a self-evaluation thing. So it's saying, look, these are the things that are important, that we know that are important to other people. If they're not important to you, then that's fine. You can say, look, this is the extent of our documentation. You can even rate it and say, well, yeah, it's okay. It achieves this goal. We're not saying that, for example, all open source projects should be thinking about safety critical software. We're saying that think about what's important to you, record it, record your reasoning about why what you're doing is enough. Actually, just going through this process may make you think, actually, no, it probably would be useful if I did some documentation. It's intended as a way of saying, evaluating where you are, seeing where you can improve, and just structuring it that way.
I would also add that because all of this metadata is managed in Git, you can raise a merge request to highlight the gap that you think is important. And if that merge request gets approved by the contributors or the maintainers of the project, they agree that, okay, yes, you have actually found a valid gap that we want to track in Git history, not just in issues. And we want to demonstrate how we will fix that gap. It kind of democratizes the process of
yeah, can I assume that you also have viewers for the metadata? And the reason I'm asking is that we work with functional safety assessors, and these guys love documents and spreadsheets.
Yes.
And
so
if I come with something that is not a document or a spreadsheet, I need to explain a lot.
Absolutely. So we have been asked for spreadsheet export. We have said no so far, but the point about this is that because it is all recorded in this structured format, there's absolutely no reason why you can't write a publishing plugin for it to do it in whatever format you like. We're producing the documentation in Markdown, which actually the safety assessors we've been working with have been very happy with. They've found that they can actually navigate around it, and because it's structured, it tells them the story. I'm trying to look for an example of the report. Yeah, so this is an example of the kind of the front matter of it, but essentially they can then drill down into this and say, so if you're representing your standard compliance objectives in here as well, then they can just jump straight to it and they can follow your reasoning all the way down. They can go all the way to the actual evidence that you're using for it, and that makes it really easy to tell the story. You might need to lead them a little bit, but that's a normal process.
Yeah, thank you very much for your presentation. On the very last slide, you showed the second tree, which was the 61508, and the breakdown. Is there some thinking about doing this also like in a collaborative effort? Because I mean, the 61508 stays the same for all of us, and it would still be a significant amount of work to do the breakdown. So yeah, what are your thoughts about that?
We would love to do that. Yes, so we're in the process of getting ourselves set up in the Eclipse Foundation. The idea is to then get people involved to work on this kind of thing. So yes, it would be really excellent to do that. We're doing it ourselves, so we will certainly be able to contribute our reasoning to that at some point in the future. But yes, really, that's the goal here, is to get to the point where we don't have to wade through the standards. We can actually look at a set of objectives that expresses what the standards are saying, and go from there.
There is a caveat though, because as Nick, in the previous talk, we saw that based on the context you're applying or trying to be compliant, you make some tailoring decisions. Some clauses you meet directly, some clauses you try to swap out with suitable alternatives. And this kind of makes it more customizable. So yes, we could make a generic template that we all contribute to as a community, but at the end of the day, at the evidence level and at the bottom, you still need to do your own work as well.
And in the same line of thought, I suppose you're working with, I guess, Philippe, right? Because you presented the same breakdown, but for 26.2. So I suppose what you did maybe for 16.1508, like they could also provide what they've done on 26.2, and if ever some open source project wants to claim cross compliance, then we'd need like any of these, right? So
yeah, that's a nice dream, but I think the problem we're really going to get to here is where does our breakdown of these standards, which you have to buy, end up actually violating their publication rules. So, which is the reason why we wanted the trustable objectives to say, look, these are the things that are important to us. This is what we think is important for software. If we need to extend that to address some of the standards requirements, then we can have that as a little safety annex. So then rather than saying IEC, you're compliant with this standard, you can say, no, you're compliant with trustable with the safety extensions, and there's an easy route from that to compliance.
So for me, the big question still is, I followed this for a while, and when my final goal is to comply with a safety standard, say 61508, why do I need to define requests and claims in between? Why not link my stuff from my safety plan, from my safety verification, from my evidences directly to the clauses of IEC 61558? So that's what we are currently doing in the Zephyr project, not in the open. So the link is there, but it ends up in a closed stuff because it would have been a copyright issue, but
it's a good question.
The link is there.
It's a good question, but that presumes, as I guess Philip's earlier talk about S-Core was a good example of this. It presumes that you're starting with compliance with a standard in mind.
Yeah.
If you actually have a development process, or if you have a set of goals and objectives which are nothing to do with that, then it doesn't make sense to say, no, we must follow the standard. Instead, we're saying, no, actually, for some projects, particularly if we're integrating software projects, we want to say, look, we want to know what evidence you have, what is important to you, so that we can then say, in our context, what else do we need to consider? So we don't want everybody to have to consider the standards. We want to have a way of them representing what is important to them, what they have considered, how they are justifying to themselves that it's important, so that you can then use that. But you're right, if you
So-
start with safety in mind, then sure, shortcut it.
Yeah, so it's more like I define my own QA assurance was trustable.
I wouldn't like to use
And
those
I
words exactly, but yes.
Yeah, yeah. I don't want to start with saying there's software process improvement. Sounds very much like something that we don't want to talk about.
The whole aim with this, and I have no idea whether we're succeeding or not, the whole aim with this is to make this something that people see as valuable to what they do, rather than a chore that they have to indulge in.
Yeah, yep.
Just a question to your question, because I thought that the standards like 61508 have a level of indirection, which is why you need this additional level to resolve the indirection. So the standard doesn't say, write your software like this and this, but it actually says, first identify what are the bad failure modes of the software you want to mitigate, which the standard doesn't know. That's task is on the person writing the software, and then put a convincing story in place how you mitigate it, and here is some additional guidance how you can demonstrate integrity on the story.
Yep.
But the story comes out of the system you're applying the standard to. The story doesn't come from the standard.
Okay, yeah. So I think the thing that we are missing here is that let's say the story why I as a project think I do the right thing is in the safety plan and is in my documentation. But I don't have another level in between. At least at the moment, I don't see the need for that. I
And
have
we're-
a safety plan that says what do we plan to do. I have a methods list. Which methods do we need to, or do we plan, or do we want to apply? And this, I think, can link directly to a standard. But yeah, as Paul said, if I want to have my own goals, I can use the Trustable to define these goals and link to that.
There's also one little practical real-life concern is most of the work done to be compliant against the standard is kept as secret source because it's very hard work and it's against proprietary standards. Everything you do against Trustable, you probably maybe want to be as public and open as possible to get as much scrutiny on
Yeah,
it.
I might want to be, or I might want to have this closed again for some project members. So that's a completely different story.
But that's a decision you can make. And and again, part of this is about how you organize the information in a way other than a spreadsheet.
Yeah, it gives people an idea to organize stuff that never had to organize stuff before.
Yep.